I guess I'll stay up and ask another question. In your section on dinosaurs, or you're going to ask me one, right? It's your turn.
Yeah. I think I just heard you to say there are areas of reversed polarity on the bottom of the mid-Atlantic ridge.
No, I said the west coast of North America.
Okay, the rest are there areas of reversed polarity.
I said areas that show reversed polarity.
Okay, there are no areas of reversed polarity off the coast of North America. There are areas of stronger magnetism and weaker magnetism. Go back and look at your own chart.
Is this your question?
It shows, yes, where are these areas of reversed polarity? I would like to see one. Show me, tell me please.
Put the remnant magnetism one back up. What? Oh, okay. The question about the reverse polarity, why is that important? Well, did the Earth's magnetic field ever reverse or not? This gives a much longer age to the Earth, and I think that's the essence of the question. Now, these areas do show areas of, as he says, more magnetism or less magnetism. What's very interesting is that if you date along these, and I know you don't go with radiometric dating either, you get a consecutive youngest age right along the ridge and consecutive ages. This is the Juan de Fuca ridge. These are, I believe, potassium-argon ages, and you can see very clearly 0 here, 2 million here, 4 million in yellow, 6 million here, 8 million in orange. And how interesting that we would get an effect like this if absolutely nothing is going on and radiometric dating doesn't work.
The fact that you can point to a textbook that shows these ages have been dated at so many million years old does not answer my question. Somebody decided the ages of these things, and it's interesting you would say they're dated by potassium-argon dating. I would certainly love to get into carbon dating or potassium-argon, any type of dating if you'd like. I was just in Hawaii a few weeks ago where they took lava that they knew erupted in 1803, and yet potassium-argon dated at 2 billion years old. Living mollusk shells were carbon dated at 2,300 years old. Freshly killed seal was carbon dated at 1,300 years old. Antarctic Journal, Volume 6. Shells from living snails are carbon dated at 27,000 years old. Science Magazine, Volume 224. One part of the Velasovich mammoth, carbon dated 29,000 years old. Another part was 44,000 years old. This is from the same mammoth. One part of Dima, a baby frozen mammoth, was 40,000 years old. Another part was 26,000 years old, and the wood immediately around the carcass was 9,000 years old. Unglaciated central, from Geological Survey, Professional Paper, 862. The lower leg of the Fairbanks Creek mammoth.
Time.
Oh, really? Oh, me.
In your section on dinosaurs, you state, and I quote, a plesiosaurus is a long-necked swimming dinosaur. And you also say, Basilosaurus is a long, skinny dinosaur that looks like an alligator with 2 front feet and no back feet. Please give the audience the scientific reasons why you lump a marine reptile and a whale in with the dinosaurs.
Okay, the word dinosaur was invented in 1841 by Richard Owen. And the word dinosaur comes from, I think, Greek and Latin, if I believe it's a combination of the two, meaning terrible lizard. That's what the word means. And so many dinosaur books that you can go to any library and pick up dinosaur books, and you will see plesiosaurs and basilosaurs and pterodactyls listed in books of dinosaurs. I think that would be a classic example of straining at a gnat and swallowing a camel. If you want to say that my definition of a plesiosaur really should be a marine reptile instead of a dinosaur, ask any kid in any school, show them a plesiosaur, say, what is it? Oh, a swimming dinosaur. I mean, so what? If it's a marine reptile, the point is, it's a plesiosaur. And if it bothers you, I'm sorry. I'll try not to call it a dinosaur, though I think it's listed in most books of dinosaurs all across the world. I don't think it's a major point at all.
Okay. Here are some slides showing some transitional forms in whale evolution. This is Basilosaurus, 40 million years. Ambulocetus, 52 million years. Notice the long functional back legs on the Ambulocetus and the much shorter legs on the Basilosaurus. Next, please. Other intermediate forms, Rhodnocetus from the Middle Eocene and the possible original form or the ancestor form of whales. Next, please. This is whale evolution, at least as of a couple of months ago, where there are a large number of intermediate forms, and a couple of them that haven't even made it to the press yet. I think there might be one more. And occasionally we do see a whale that belies its evolutionary history by having contained in its blubber some sort of vestigial like substance.
Give her 30 more seconds. I need to see. I don't mind. You got more stuff?
No, I'm done.
Okay. The whale evolution. I don't know that I'll have time to get into all of this. I'd love to get into some of these.
You're supposed to ask me. This is the next.
I don't get to answer, respond to hers about the whale. You just get up here and say whales evolved?
No, the format is that you ask a question.
I thought we were supposed to have a discussion on the topic.
No,
Oh, you don't want a discussion on that topic?
not really.
Oh, because I can show you about the whale evolution if you'd like. You're simply wrong about that. Okay. Well, you asked me to keep questions from my seminar notebook. I think you're 0 for 1 on the first one. Where did time, space, matter come from? If you want to stick with biology or with chemistry, which is your expertise here, can you explain to me how life got started from non-living material? Has anybody ever observed this happen? Is there any scientific evidence that it can happen, other than Miller and Urey's experiments of making a few amino acids, which is a far cry from making life, which we'll be glad to talk about if you'd like. But I'd like what evidence you have of how life got started, and corollary to the question, when, where, why, and how did this life learn to reproduce itself? How do you go from asexual to sexual reproduction?